Hello my dear students, welcome back to the class. The last video we have discussed about determination of density of solid by using a measuring cylinder and determination of irregular solid by using a Eureka cans with the help of Eureka cans. Okay. So today we are going to discussing measurement of density of liquid by using a density bottle. Okay, measurement of density of liquid by using a density bottle. So how can we measure the volume of liquid with the help of density bottle? You have any idea about this? Okay, no problem. Let's come to the class. See, this is what density bottle, 50 ml density bottle. Okay, this is a 50 ml density bottle. Okay, so this 50 ml density bottle that's having what, one stopper and one center this tube, that is capillary tube. Okay, this is what stopper. Okay, see this density bottle, that is a transparent glass bottle. Density bottle is a transparent glass bottle, and this bottle having what, close fitted round glass stopper on the neck. Okay, round glass stopper on the neck. This is the glass stopper, and inside there is small one tube, that is called capillary tube. Inside there is one small tube, that is capillary tube. Is it clear? When the bottle completely filled with liquid, okay, when the bottle completely filled with liquid, and then we are insert the stopper, okay, when the liquid filled in the density bottle, okay, then after what we are doing, just insert the stopper. Okay, when the liquid completely filled in the density bottle, then insert the stopper. Excess liquid that rises up to a capillary tube. Okay, excess liquid that rises up to the capillary tube and drain out. When we are filled the liquid, okay, and then after insert the stopper. Okay, stopper having what, the capillary tube. Then the excess liquid that rises up to the capillary tube and drain out. Okay, and drain out. Is it clear? Okay. So this helps to the what, equal volume of the liquid when filled with different liquids. Okay. So now you know that how to fill the liquid. Okay. Okay, so how to measure the density of liquid? Take 50 ml density bottle and wash with distilled water. Okay, take the density bottle and wash with distilled water and dry it. Okay, then measure the weight of this density bottle with the help of physical balance. Fill the density bottle with the distilled water and insert the stopper, then dry it. Wipe the bottle dry from outside. Now find mass of physical balance. Okay. First, you want to wash the density bottle with the distilled water, then dry it. Okay, then after take weight with the help of what, physical balance. Okay, and the second step, fill the density bottle with the distilled water and insert the stopper, then wipe out outside. Okay, then again then dry it, then take the weight. Okay, take the weight. Okay, and next is third step, pour off the water from the density bottle. Pour off the water in the density bottle and dry it in the hot air. Dry it in the hot air and fill with what, given liquid. Which liquids is given to you, then fill it. Any liquid like a kerosene, alcohol, brim solutions, etc. Okay. Next, then what? When it is completely filled, then insert the stopper and wipe out the outside and dry it. And again take the weight. Again measure the weight with the help of physical balance. Okay. So what are the observations we will get? Just see. So what are the observations? See, first, mass of empty bottle, that is we will take what? M1 gram. Okay. Mass M1 gram. M for what? Mass. Okay. So that we will take M1 gram. Okay. And mass of the bottle, empty bottle plus water, with the water. Mass of empty bottle with water, that is M2 gram. We will take M2 gram. Okay. And next is mass of empty bottle plus liquid. Mass of empty bottle plus liquid, that is M3 gram. Okay. So first we are filled with, first we are would take the balance, empty bottle. First we took what? Empty bottle weight, that is this one. Okay. Then after we pour some distilled water, then we took again what? The weight. So that is M2 gram. And next is the third step, mass of empty bottle plus liquid, which means what? After drying, after removing the distilled water, we are drained out with the help of hot air. Then with the hot air we are drained out the density bottle, then filled with what? Given liquid. Okay, which liquid they are given, that we are filled in the density bottle. Then we took what? Weight, that is, then we will get one weight, that is M3 gram. Okay. And next, therefore, mass of only water. So we need to find the mass of water. Okay. So this is the water, empty bottle plus water. This is the empty bottle weight, value. Okay, M1, and this is with the water value, that is M2. So how can we find the value of? How can we find the mass of water? Yes, of course, we need to subtract the step 2 to subtract from 1. Step 1. Okay. So that is what? M2 minus M1 gram. Okay. M2 minus M1. M2 minus M1 whole gram. Is clear? Okay, so now we are at the mass of water. Just think about 1 gram of water. 1 gram of water, so that is 1 centimeter cube. That is the volume. Okay, 1 gram of water, that is equal to 1 centimeter cube volume. Okay, and the next is therefore the volume of water. What is the volume of water? Okay, volume of water, how can you calculate? Yes, that is also same thing. M2 minus M1 centimeter cube. This is case volume. This is mass. We find the mass, and this is the volume. Okay, M2 minus M1 whole centimeter cube. So the volume of bottle. What is the volume of bottle? See, we need to find the volume of bottle. So how can we find the volume of bottle? Same thing, M2 minus M1, that is centimeter cube. Okay. Therefore, the volume of liquid, that's equal to volume of water, that's equal to what? M2 minus M1 centimeter cube. Okay. Also, mass of only liquid, that is M3. Okay, liquid, that is M3 minus M1. We need to find only liquid mass. We need to find only the mass of liquid. So M3 minus M1 gram. Therefore, the density of liquid, that is equal to mass of liquid upon volume of liquid. So the mass of liquid, that is what? Mass of liquid, that is M3 minus M1 per gram. Okay, and volume of liquid, that is minus m1 gram per centimeter cube. Okay, so once again, density of liquid, that is mass of liquid upon volume of liquid. The mass of liquid that is given here, that is m3 minus m1, and from volume of liquid, that is m2 minus m1. Okay, gram per centimeter cube. Clear? If the mass of liquid 42 gram, so just think about, if we given the mass of liquid that is 42 gram and the volume of liquid that is 50 centimeter cube. So how can we calculate the density of liquid? Okay, so density of liquid, that's equation, mass of liquid upon volume of liquid. So mass of liquid that is given here, that is 42 gram. How much? 42 gram. And the volume of liquid, that is 50 centimeter cube. Okay, so put the values in the equation, that is 42 gram upon 50 centimeter cube. So we will get 0.84 gram per centimeter cube. Okay, we will get 0.84 gram per centimeter cube. Is it clear? So in this way we can able to find the density of liquids. So next we are going to discussing of density of liquid and gases with temperature. We know all forms of matter like solid, liquid and gases expand on heating. Okay, all forms of matter that expand on heating, that we know that, and when it is cooled down, it is contract. So all forms of matter that is expand on heating and contract on cooling. Okay, that we know. Case of solid, the expansion with the rise of temperature. If it is small temperature we are given, there is no expansion. Okay, but the volume of solid, that is hardly change temperature. So the density of solid what is equal to mass by volume. That we already know that how to find the density, that's mass by volume. Okay, so in case of solid, when we are rise up the heat, that is temperature, rise the temperature, the volume of solid, it's hardly change. The minor changes in temperature, the density is not changed in case of solid. Okay, the high temperature, the volume of solid, it will be changed. Okay, hardly changed. But in case of minor variation in the temperature, there is no change in the volume. Okay. In case of liquids, in case of liquid and gases, there is large change in the volume. So the density of solid does not change. Okay, volume will change and the density of solid, that will not change. Okay. So in case of liquid and gases, the volume will change, rise in temperature, but the mass of gas or liquid, that's remain in same. So in case of liquid, in case volume increases with the rise in temperature, decreases. In case of solid, the density will not change with the rise in temperature, only the volume has to be changed. Okay, but in case of liquid and gas, in case of liquid and gas, in the rise in temperature, volume is changed and the density is also decreases. So now we are going to discuss what are the consequences of change in density of liquid with temperature. What are the consequences? When we heat the water, not only water, if any liquid, okay, when we heat the liquid with beaker, liquid in beaker or any vessels, okay, so the bottom of the water, okay, close to the bottom of the vessel, that start to expand. So the density of that water is decreases, liquid that is decreases. So this liquids that rise on the beaker, rise up the beaker, and the upside, which one is the upside one, that is cold one, that comes towards the bottom. Okay, so this process, this is one type of current set up in the water. Okay, so this current produced water, this is known as what? Convection current. Convection current when the water heat up. So the bottom of the water close to the water vessels, it will be start to expand. Okay. So now here the density of the water very less. Okay, density of the water is decreases. So this denser water that raised up to the beaker. Okay, this less denser raise up and the cold one that comes down. Okay, so this process, this is one setup of what? Current. This is current setup. So this process is known as convection current. Okay, so this convection current that produce what? The liquid to heat. Convection current produce the heating of liquid. Okay, so this is the reason for what? All the side, okay, all the liquid attain the same temperature. Okay, clear? Okay, and the next one, consequence of change in density of gases temperature. Okay, so it's same thing when we are heat up the liquid, it's the density will decreases and this comes upside and the cold one comes downside. And the same process occur in the case of gases also. When we are heat up the gas, it will expand. Okay, and the density is decreases. So this lesser denser gas that comes out rise up and the more denser that comes downside. Okay, this convection current that's responsible for the formation of weather, like this sea breeze and the land breeze, and we are keeping ventilators in the roof. Thank you.